Welcome to On the Go with AAUW. I'm Jill Caparelli, and I'm Assistant Dean for Biology at Northern Virginia Community College, the Annandale campus, for those of you who live in the area. And I'll be your host for today's show. We have a really exciting episode today. It's about fungi. And to talk to us about this strange and wonderful world of fungi is a high school student, Meredith Keppel. Welcome, Meredith.
Hi, thanks for having me here, Jill.
It's good to have you on the show, and I'm so excited that we have somebody, a young person, so excited about science. So what got you so interested in fungi?
Well, I think about 5 years ago, I had a science teacher, Mrs. Blythe, who for some reason saw some potential in science for me, and so even though I hadn't been the best student in her class, she gave me a full scholarship to a summer camp in Southern Virginia called Nature Camp. And at Nature Camp, I met people there who were really passionate about all these different fields of fungi and of plants and of trees and stream and all sorts of stuff. And one of the people I met, he actually introduced me to these relationships about between trees and fungi called mycorrhizal relationships. And I was hooked. I was like, this is fascinating. How did I never know that these tiny little organisms were so helpful in doing so much?
So, we walk on the, in the forest and everything, and you see a little fungus, the little cap.
Yeah.
Is that it? Or what else is going on underneath the forest floor?
Well, actually, that's not it. A lot of people don't know this, but fungi refers to the entire organism. And what you see above the ground is a fruiting body, what we call mushrooms. So in many cases, you will see the top part, which is the stalk and the cap, but underneath is the main part of the organism, what we call the mycelium. And it's kind of like a root network system. If you've ever flipped over a log after it rained or something, you might see like a spider web kind of thing that's maybe a little flexible and spongy, and that's probably mycelium that you're seeing on the bottom. And it's actually estimated that when you go in the forest, for every footstep, there's about 3 miles of mycelium in 1 cubic foot underneath your foot. So
that's amazing.
It's a pretty dense matrix.
So you talked about a relationship between the trees. You started to mention
Yeah.
that. So tell us more about this relationship that trees actually have with fungi.
Yeah, it's fascinating. When I first got into mycology back in 2012, that was a really big year for mycology and forest ecology. A woman named Suzanne Simmert, she teaches at the University of British Columbia in Vancouver, and she published a paper about this relationship, and she had been able to prove the connection between the two. And I remember seeing news stories when I got home that were like, trees talk, and everyone was kind of amazed. But there is in some cases it's ectovascular, and sometimes it's endovascular. So the mycelium and the tree roots will connect together, and some people have the misconception that it's a one-to-one kind of relationship, one mushroom to one tree, but actually the mycelium will form this network that covers the entire forest and connect to, if not the entire forest, then a large portion of it. And they'll kind of filter things, and what happens is the tree communicates through it. They give nutrients back and forth. The mushroom produces toxins and enzymes, kind of like we produce, and that they'll give that to the tree to help them grow faster and stronger. And then the trees can send enzymes that will communicate to other trees through them, and they'll give the mushroom nutrients that they've collected through photosynthesis and all sorts of stuff. They're really cool.
So you also mentioned that it doesn't only communicate between tree and mushroom. When we talked before we came in, it helps the trees communicate with one another and give them nutrients. Why did you talk?
So some of the research that was happening was they were trying to see how exactly the mushroom acted as, because they had this suspicion that the mushroom was doing more than we really gave it credit for. And so they're trying to see what exactly the mushroom's role was in this relationship. And so they had taken 3 trees and 1 mushroom, this mycelial network, and all 3 of the trees were connected. And then they kind of created this controlled environment where they shaded one of the trees. And of course, shading a tree can be really detrimental to its health. It can't photosynthesize and get all that sunshine. But what they saw the mycelium do was the mycelium took the nutrients from the other 2 and kind of evened the playing field. It kind of supplemented what the other tree was lacking. So maybe the 3 trees weren't doing as well as they might have done, but they all were going to survive and be healthy. And that mushroom played that role of kind of Mother Nature in making sure, in fostering and shepherding all of these different trees to make sure everyone was going to survive and do okay.
It's amazing that it's helping the trees, and
yeah,
it's not
to have
just
that kind of
living
intelligence
off the trees.
To have that kind of intelligence, to know when one was lacking, and then to take from the ones who had the most. It was very Robin Hoodish.
I think when most of us think about fungi,
yeah,
we and medical research, we think about penicillin.
Oh yeah, of course.
So, but there's a lot of new medical research occurring with mushrooms. So why don't you give us some information, because I thought that was fascinating. I actually watched Meredith has a TED Talk, and so we'll have to get you that information. And she talked about a number of different types of research that's going on. If you could fill us in, that'd be great.
One of the interesting things is I'm still a high schooler, and trying to dive into that world of medicine was really difficult to sift through the medical jargon. But one of the things, there's a lot of great resources out there to kind of help you with that. And one of the things I really learned was one of our biggest problems, I mean, at the same time that at penicillin, that breakthrough, right? Necessity is the mother of invention. So when penicillin was coming in, there was all these problems with bacteria, and now one of our greatest problems is cancer. So one of the biggest things that we've discovered is fungi can cure cancer in many different ways. 3 specific organisms I'll touch on really briefly is that there's turkey tail, which can be really effective as an immune booster, and specifically it's been used in trials with breast cancer. And women undergoing breast cancer with stunning results. There was one woman, I read her case file, that was talking about how she was like an 87-year-old woman, very elderly, and she had been diagnosed with stage 4 metastatic breast cancer. Her doctors told her she had mere months to live. Because of her age and her immune was compromised, so they told her she couldn't do chemotherapy. But when she entered this trial, they gave her Taxol and Herceptin, which are 2 cancer drugs, as well as 8 turkey tail capsules a day. And a year later, she was not only living, she was cancer-free.
Wow.
So that kind of stuff, it's happening, and it's really amazing what it can do. Another one is cordyceps, which can do some weird other things we might touch on later, but cordyceps has also been used to treat kidney cancer. And then liver detoxification for reishi mushrooms. Reishi has been used to enhance liver detoxification, which can really help when treating liver cancer. And of course, all of these boost your immune system, and actually they've all been known for a long time in the Western world, in the Eastern world, to really boost your immune system, and been brewed in teas and things. But there's a kind of fear of fungi in our Western culture that's prevented us from utilizing this amazing resource.
The idea of psychedelic drugs and I guess
and
like
poisoning by
and
things.
There are a lot of poisoning. You can't go out there alone.
No, of course. Foraging is really a passed down art. I mean, you can look at a textbook as much as you want, but you really need to have someone go with you for months when you're going out foraging to really have confidence in just your local ecosystem. It's a passed down art that way.
Right. And in the area, you said there's actually an organization.
There is. There's I think it's the Washington chapter of the Mycological Association. And if you go out there, find it on the internet, a quick search. They have forays where they go out and the masters will teach the students. And there's a lot of really cool opportunities if you just look for them.
So who's your mushroom idol?
Paul Stamets, actually, that guy, he is my idol. He's been amazing, the research that he's done and the lives that he's really helped. He actually has 2 TED Talks on mushrooms,
very cool.
And his TED Talks were definitely inspirations for mine. And we had a really cool moment where I love his work, and I've been a really big fan of it for many, many years. And he happened to watch my TED Talk, and he connected through the TED platform to my organizer and got my address and sent me a signed copy of his book.
Nice. Yeah.
It was incredible. I might have freaked out when I saw it, just potentially.
That is so great. So you also got interested in using mushrooms for sustainability.
Yeah.
Can you explain how you can use mushrooms for sustainability?
Well, sustainability is kind of my focus. It's where I want to take myself. I mean, I'm a high school senior, so college and career is really on my mind.
So much for a high school senior.
College and career is really on my mind right now. And moving forward, sustainability is really what I want to study. And one of the things that got me into sustainability was this mushrooms. And in fact, they're being used in a technique called bioremediation. Bioremediation is the use of plants to remediate something that's an ecosystem that's been heavily damaged to potentially the point that humans can't even live in it or anything like
Different
that.
Different types of toxins.
Yeah, all sorts of chemical spills, a lot of brownfields and things like that, which are listed on government sites. But another subset of bioremediation is mycoremediation. And mycoremediation is using mushrooms. And so one of the things that they do is mushrooms, many different types of mushrooms actually filter heavy metals. So things like mercury and all sorts of other lead, all sorts of the other things that are really toxic to our systems. They also, so if you think about it, mushrooms are decomposers. And the basic thing that they break down is plants and animals that are rotting in the ecosystem, right? And if they weren't to be broken down by mushrooms, those bonds and those things would be compressed and potentially sequestered into fossil fuels. And those fossil fuels are what are actually causing a lot of destruction in our environment. But because that same chemical structure exists within them that we would have if they were breaking them down before they got sequestered over millions of years and were able to form fossil fuels, that's why mushrooms are actually being able to break them down. One experiment, Paul Stamets, that same mycologist, he took 4 different piles of kind of soil that had been drenched in petroleum, and one of the piles he used as his control, as any good scientist, and one he put bacteria in, one he put enzymes, and the last one he put oyster mushroom spores, which were behind us a little while ago.
Okay, not right now though.
And what he found, he left them, covered them for 8 weeks, and came back and found 3 nasty, stinky piles, as to be expected. And the 4th pile, the oyster mushrooms, not only had they broken down the hydrocarbon bonds, they had broken them down into glucose and left behind what was practically sugar. So it attracted all of these, it actually left behind carbohydrates. Yeah, there you go. There's the oyster mushrooms.
Okay.
It left behind carbohydrates.
It's a beautiful mushroom too.
Yeah,
it is.
It's gorgeous.
Functional. It's beautiful.
It left behind carbohydrates and glucose, which attracted insects, and those insects worked to make it into soil, and the insects actually attracted birds, and the birds left behind seeds, and all of a sudden there was this plush new ecosystem where before we may have left it as something that was completely dead. So that work of what they can do to rehabilitate sites that we've really heavily damaged and impacted, both water sites and sites on land.
Yeah, so how does that work for riparian?
For the riparian buffers,
For riparian buffers. Explain what a riparian buffer is to everybody, and then if you could explain how they're now using mushrooms.
So for many years, I have actually worked with Goose Creek Association, a local organization, to stream monitor different sites in Loudoun County in the Goose Creek watershed. And one of the things that I've learned over the years is that there's a lot of fertilizers we put on our crops, specifically nitrogen and phosphorus. And those two are nutrients that don't easily dissolve in water. And so when they flood the ecosystem, the aquatic ecosystem, they cause an excess of algae, which then eventually leads to a dead zone. And so that's what we call eutrophication, that process of excess nutrients. So the runoff from the kind of those farms specifically also cause E. coli, and that was what I was measuring. The E. coli is in the waste of farm animals, which is often an indicator of that eutrophication. But what we can do is, in riparian buffers, is a technique that we've been implementing with Goose Creek for a long time. It's a gradual placing of plants along a stream bed to protect it from erosion and runoff, and then also
the standard way. But this is so interesting what you're doing with mushrooms.
Instead, with mushrooms, we kind of add to it. We add a kind of burlap sack almost that we've stuffed with a substrate, coffee grounds and all sorts of good things that mushrooms love, and then inoculate it with mycelial spores. And when you place that along the stream bed, not only does that cache the nitrogen and phosphorus and other organic waste that will cause problems in the water ecosystem, it also will add to the actual ecosystem, encouraging those mycorrhizal bonds and keeping the stream bank together. And it can filter out the road runoff from the heavy metals. And so it's actually 10 times, in some cases, more effective than these just plant riparian buffers. Adding that mycelium there can really help.
So it forms like a network. It almost forms like a glue or something like that?
Yeah. So mycelium goes through external digestion, and when they are done, they excrete their waste products in a glue-like enzyme that actually is what holding the water or the soil together, more so than the stream plants, their roots. So, yeah.
And it can be used as sort of a plastic substitute or something?
Well, yeah. So that side of the coin is Ecovative. That's where they really come in. Ecovative is a newer company, and they actually are really working in packaging materials. Okay. They're trying to replace specifically styrofoam and other plastic packaging with mycelium, and they're really amazing at it. The mycelium that they've been able to grow in the lab and then use for companies like Dell and Amazon and all these different companies that are starting to integrate this into their packaging.
So when I get something from Amazon now, is that mycelium packing? Can I eat it afterwards?
Well, I wouldn't suggest eating it.
I guess not. No.
But what you can do in many cases, the way that they grow it is so that it's easily able to incorporate into your garden as almost like part of your compost or your mulching, because then that, of course, encourages those mycelial relationships that will help your garden grow faster. Right. And unlike, styrofoam takes thousands of years, if ever, to break down. And these mushrooms, not only do they break down faster if given the right conditions, they're also, when used as a packaging material, they're flame retardant, they're waterproof. They don't include these nasty chemicals like PCBs and all sorts of nasty things. So, it's, in my opinion, a clear-cut choice to choose this packaging material.
So I also wanted to mention one other thing. You're homeschooled.
I am.
But yet, in addition to your homeschooling, and in addition to your internal amazing drive, you've also taken some courses at
Nova,
which is where
the Northern Virginia Community College. I take it at the Loudon campus, though, unfortunately. But this semester, as my senior year, I'm taking chemistry and calculus at the community college near me, and I have really enjoyed it so far. Nova's been really great. They've really worked to include the dual enrolled students and to create a community network, and they have a lot of resources available if you need them.
Yeah, we're very happy about it, Nova. And so not only do we take, our sort of traditional students and dual enrolled.
Yeah.
If you're 16, you don't even need to, graduate, and you can just come to Nova.
And that's been a real difference from my other experience. I was actually a few years ago a part-time student at the local high school, and there's a lot of problems that we face in Fairfax County. Has really struggled to fully have the stuff that they want to incorporate. The homeschoolers who are part-time enrolled aren't allowed to participate in after-school activities like clubs and things. And as a French student, I wasn't allowed to be in French club. I wasn't allowed to go to any of the dances or anything. So it's been really refreshing to be at Nova, where everything is, you're practically a full student. You could do anything that a Nova full-time enrolled student could do.
So I'll put a plug in even on the other side. So that's the young side. And then for the old side, I'm going to put a plug in. You can, if you're over 65 and you're a resident, and if there's a space in the class, you can take it for free.
Wow, I didn't know that.
Yeah,
that's so cool.
Maybe there's a minimal transaction charge, but so we'll put that plug in. So what are your next steps?
Well,
what
college,
do you
hopefully.
Do? Okay, and what do you want to study in college?
I
What
would
will be your
really like
major?
to study environmental science, and specifically some of the schools I'm looking at, they have a track for sustainability within that. But eventually, I plan to pursue my PhD. But currently, the 5-year plan is to work towards getting my bachelor's and then going into the Peace Corps for a little while. I think especially as science people, we have a hard time equating our real life laboratory work. We like to work for the sake of science, but sometimes in sustainability, it can be really nice to get that kind of touch in with real life, to know what the real world problems are. I think working in the Peace Corps can really give me that. After 4 years of academia, going to the Peace Corps really gives you that touch for this is what I'm working towards, and these are the people I'm trying to help.
And do you want to do sort of like bioremediation in the Peace
Yeah, that'd be
Corps
great.
or something
I'd
like
love
that?
to do whatever I can to help where I'm needed.
And, you know, I wanted to ask you a couple of other things. So, what other types of relationships or symbiotic relationships do you see with mushrooms? What other types?
Well, it's interesting you ask because fungi are actually, I mean, when you're looking at the progression of an ecosystem and the succession, the first organisms you see there are fungi and lichen, and those they're what start the whole ecosystem. They're the very foundation. So I mean, when you don't have them there, that they're such an integral part that they're practically involved in everything. So I mean, you see them for decomposition. Right. There's parasitic relationships. You have the mycorrhizal relationships where they help them grow. Even within fungi, there are relationships between organisms. I mean, lichen, it's a common misconception, but lichen is not actually one organism. It's 2 or sometimes 3 even organisms, and that's really cool. Lichen is cyanobacteria, so a blue-green algae, and then one other fungi, or potentially even a third fungi, which we've recently discovered, and it's kind of thrown everything we know about lichenology on its head a little bit.
Right, and it's that first species that comes in. It's that pioneer species.
Yeah.
When you can break down rocks. Do you want to explain that, like how it contributes to succession?
Yeah. So when you first have an ecosystem, if you're going through primary succession, you
right,
don't have
very
you
good,
don't have
very
any.
good.
Yeah, I've taken science classes.
See? Yes.
You don't have any dirt at all. You would only have rock, and that lichen and the fungi actually work to create the dirt by over millions of years in some cases, or in other cases thousands, working to grind down that stone into dirt that can eventually, you'll get your ferns, and then your short grasses, and eventually you'll get your sun-loving trees, all sorts of stuff. I did pass AP Environmental Science, so
very good, very good.
So eventually you'll get there, but no matter what way you cut it, the foundation of your ecosystem depends upon that relationship with fungi, and that's one of the things that my colleagues Paul Stamets said, is that the strength of an ecosystem is a direct measure of its fungal diversity. I think that really perfectly sums it up.
Right, so explain that a little bit.
So when you have a lack of mushrooms, not only do you lack that extra strength that you would think of, it doesn't give those extra toxins and antibiotics to the trees and other plants, you really lack it. Because, I mean, there are even fungi kingdoms within the plant community that or families within the plant kingdom that can't exist. The heath family depends upon that heath fungi to be in the soil in order to grow. So you really, not only is it like, if they were there, that'd be great. They really need them there, not only to cycle those nutrients, but also to create those relationships that plants heavily rely on. So I don't think it's a question of should we have them. It's a question of how can we live without them.
Right. Right. And so you've done other speaking engagements.
I have.
Where else have you been speaking? And do you have any engagements coming up? So if people want to see you talk.
I don't actually have anything coming up at the moment. It's been a very nice year of working hard at college applications. But I actually got my start in 2015. A friend of mine is the president of our local, the Herndon Environmental Network, Ken, and she was nice enough to meet with me once and be like, you really should teach a class on this. I said, class? Me? I can't teach these people. And so I've taught classes at symposiums. I did an environmental green breakfast, the Northern Virginia Soil and Conservation District. Harry reached out to me, Harry Glasgow, who's their vice president. He reached out to me and said, hey, you wanna do this? And so a few years ago I did that. I did my TED Talk. I've taught at multiple garden clubs. I gave presentations, and I've been privileged enough to listen to other presentations as well. So it's been really, really privileged to do all that I have. So.
And you have a very supportive family.
I do. I have a lot of support coming from them.
Which is great for someone who's homeschooled. You have other interests. I just wanted to touch on them. So you've done some work for the Loudoun Habitat for Humanity.
I do. I did. I actually was their vice president of their Youth
Very
United,
cool.
and then I was their office intern. Great ladies working there. They're really nice.
And you do work for LGBTQ Sharing Circle.
I am the creator and the co-founder, or the co-facilitator at the Sharing Circle. I help.
So what is a sharing circle?
It's a support group. I help facilitate the space to kind of bridge the intergenerational gap in the LGBTQ community. I help teams to kind of come into the community in a way that's, you know, maybe not dating related, just so that they have those relationships. They kind of touch in with their history and where they've come from and where our struggle has been, and kind of get that support for, you know, knowing that you're not the first generation to go through this, you're not the only one going through this, and that it gets better.
You know, it's been a fascinating conversation, and it was so wonderful to meet you. I am so happy for you to come and teach us all a little bit more about something that we step on every day and eat every day.
Yeah.
Thank you very much,
Thank you
Meredith.
so much for having me here, Jill.
It's wonderful. Thank you.